So all credit goes to these folks over here, especially Dr. Sanchez. He has developed most of this content, all of it. It's gonna be d density divided by density t plus not that. That's not right. No, that is right. It's dotted by no, it's not a dot product. It's a vector, so it can't be a dot product. So I don't know what I was thinking, but yes. So let me feed dot. No, I keep on doing dot. It is parentheses density and v equals 0. And now that's the continuity. Now momentum. Now here's momentum, which should be dv dt. Oh, by the way, this is for incompressible. No, compressible. For incompressible, density is deleted, and then it becomes a gradient dot v equals 0. That is our definition for incompressible. Anyways, so on, and this is equal to no, this is wrong. We have density here, density parentheses dv dt, and this is all from memory. There's no looking up, no help from anything. We'll see if I can get everything, and if I can, then we move on. But chapter 1 and part of chapter 2, because I realized chapter 2 has been changed, so we're gonna have to review that. But it's gonna be plus I believe gradient dot this and that with a double bar. Am I forgetting something? No. I don't think so. And then there's the energy. Oh, yes, I forgot something. Not many. I almost forgot to write tau. What is tau? Well, tau is mu parentheses gradient v plus gradient v transpose, and that is equal to I believe is plus parentheses mu b bulk viscosity plus 2 divided by 3 mu parentheses this is I double dot. Now, if I get something wrong, we're gonna restudy it. So next is energy. Which is going to be, I believe we still start with density, and we have dE dt, which equals to density parentheses dE dt plus v dot gradient E. Okay? Equal negative p gradient dot v, if I remember correctly, it is because it has to be a scalar, and it'd be plus double gradient dot gradient v, and then minus, almost got this one wrong, gradient q dotted. Okay, and then we can transform this. So by invoking thermal states, the states equations. Now we need to now remember the states equations, which start with H equal E plus P divided by density. Okay, and now that is one density. We also need to state E equals CV dt, and then that means E equals CVT, which means that we can transform this H equals CVT plus P over density, and we need to state our ideal gas law, which is P over density equal RGT. Now we need to state our RG, which must equal 287, I think. And then we need to state this, which is 1.4 for gas, and we're only dealing with gas, basically. Then we have to state what that equals, which is CP divided by CV. And then we need to state our RG, which is equal to CP minus CV. We can claim all those. And then that's it. That's all I can say about those, I think. Anyways, with that thing, we can claim this portion too. Because this is RG, T, H must equal CV plus RG parentheses T, which means that H equals the what's it called again? CP, specific vol no, it's specific something pressure. I forgot what's the name of this. Okay, but we get this form, which also means dH equals CP dt, but because CP and CV usually are considered constant in every case, but I'm not sure if it's the same for gas. I wish I could buy the book right now, but let's just say it's not we're not gonna say anything. Anyway, and then next we have to claim our ds equal E plus I believe it was called dP over density. No, that's wrong. That's the other version. Which is gonna be P over D parentheses 1 divided by density. We know this one, and then we have T ds equal I believe it was CV dt plus P, and then we have a negative here. We must remember that quotient rule. So if I do D 1 over density, then that would equal low D high. So low D high. No, high D low, low D high. High over here, which is 0, minus low D high, and then low low, so square over here. Now that means that this equals P over density squared P assure. What does that really mean? I think I did this wrong. Yes, again, density. This means that we have T ds equal CV dt, and this can change into, well, let me get my my tablet just crashed out on me. What's going on? It should not have happened. Okay. Anyways, we'll continue. And then we have RG, and no, we can't do this yet. We need to divide by t first. We divide by t, we divide by t, and we divide by t here. So p t over density, d density over density, which equals ds equal cv dt t plus rg, d density over density. Now we have all this. We have this final form. Now we can get this equal to other stuff. But first we need to get our second form out, which is going to be over here. What's our second form? I believe it's CP next. Let's see, and how do I get that? Well, we have to get the other form of this, right? And how do we get that? Ah, state equation, right? It's always some kind of state equation. P over density, right? And then E equal H minus P over density. And then it's DE equal DH minus D P over density, right? So DE equal DH minus P D parentheses 1 over density plus this minus this minus. So it's 1 over density dP over here. And we plug that into the original one. Oh, this is supposed to be a D. I forgot the D in here. So we said T ds equal, I never memorized the other one I told you, because I always forget the other one. Plus, what was it called again? I believe it was P d 1 over density, right? That's the only one I remember. And then T ds equal dH minus P over D 1 parentheses density minus this is the minus, right? Yeah, I knew something was wrong. It's supposed to be minus because there's a square over there. I almost didn't write it down properly. Yeah, it's always minus. Don't forget that. And then it's plus minus. And then, oh, are we putting in all the other stuff? Okay. Uh, let me put in the 1 over dp over density, and then it's plus p d 1 over density over here, and cancel these two out, and we get t ds equal dh minus dp over density, and which this it will give you over here dds equal what is this? What is dh? That's cp over dt minus dp over density. So that's ds equals cp dt over t minus 1 over density t dp. Wonderful. So we have this form. What does that give me? I think I did something wrong again. Um, did I do something wrong? This doesn't seem right. I don't think I think that's right. Okay, we're gonna have to continue. Yes, I think I'm right. I believe then it was rho t divided by, which is then we have p over here, and then we have rg, I believe. Oh, yeah, we got it right. So ds equals cp dt over t minus rg dp over RG, I think. No, over P. Sorry, my apologies. And then we're gonna do the sneaky trick of P over rho ln equal what's it called again? Ln of RG T parentheses. We have ln of P minus ln of rho equal ln of RG plus ln of T, and we can take a derivative. So dd something. What do we call it? Actually, it's called differential derivative, so it doesn't really matter. dp over p minus rho d rho equal nothing over here and plus dt over t, and then we have this form over here. This form can be put into here, which is ds equals cp parentheses dp over p minus d rho over rho minus parentheses rg dp over rho. And then we can see this as I believe cp and cp can be something, but we see that that would mean that I need to turn this into cp minus rg parentheses dp over p, which let me check. I believe it was rg equals cp minus cv. So if I have rg minus CP that equals negative CV, and then CV must equal R CP minus RG then, and which we have. So minus, and then we have minus CP over rho, and then rho. So I can erase this part and give you that part. Okay, and then that means I will have ds equals cv dp over p minus cp rho rho rho. As you can see, what I'm trying to show you here is that I only memorize a few things, and the few things I do memorize allows us to do that shit. Anyways, next thing we have to do is realize this portion. This is the next thing I will do. Once I was able to set myself over here to get this. And anyways, over here we'll use the idea of dh equal de plus d, I believe it was Well, I think it was something, it's a differential of that, right? I don't remember. No. Why am I blinking out here? I think it was dp over d over rho. Why I did this? So I'm assuming density is constant here. Yeah, here. Now, in usual other cases, you have to do this form over here. We have to endure to get into a certain format. What did I do? Yes, you have to do this thing most of the time. But since we're going to say density is constant for now, we can say rho so dE equals dP over rho, and this will be considered, I believe it was minus dH. So it's going to be no, plus dH and minus. So dH over dt, and then it's going to be parentheses, and then it's going to be minus 1 divided by rho dP over dt. Total derivative and normal derivative is the same thing. It always confused me a long time ago, but not anymore. It used to. Oh, I know what I'm forgetting. I'm forgetting this term. What is Q? Q equals negative K delta T, as everyone should know, minus Q dot negative K delta T parentheses. Now we have that. We have everything here. We have everything here. Now the next thing we need to use is TDS. I believe it was equal to DH, and it was plus dP over rho, I think. And I said I don't memorize this, so that was because I always do this process to get this form over here. Where's that form? Over here. But I guess I did. I see I made a mistake again because I didn't memorize this one. This one is not memorized by me, so it's a minus. Looks like. Wait, that doesn't make sense. It should be a plus. Did I make a foolish mistake here? No, I didn't. Oh, okay. Yes, it was supposed to be minus. Okay, eraser. I derived earlier, so it's fine. Why I say this is because this is how I double check if this thing is correct by checking this stuff. If this is correct, then I have no problems of going further with the application. So it's like this. I would plug the h over here, which will give you rho parentheses uh, d, and t is constant, so we move it out. S, small s, dt. I should put that small. That looks like a big S. And then it'll be plus dp 1 over density dt minus 1 over density dt bp, and then you see that it cancels out, and everything else stays the same. So let me just give you the final version. T density ds dt equal negative p direct dot v plus double tau double dot gradient v and minus a gradient of dot q, which I should probably change to the later version, which will give you the final answer of that gradient negative k delta t to say this, but I think that's it, right? No, I think I forgot something. Euler's equations, Euler's equations, Euler's. I call it Euler, but it's Euler. I'm always wrong about that. And then the simplified version of that. So next we're gonna go into Euler, which you may remember it as Euler, but equations. Now, Euler's equations will tell me the RE is much greater than 1, which is density, U infinity, and length, no, yes, length scale, and then mu. What is this important here? So if I miss something, I'll consider it wrong and I'll redo that portion. But we'll start over here, go over here. The rules over here are basically you go from each thing. So what is convective term? Convective term is U infinity, and then U infinity squared divided by R, right? R is one portion over here, and then there's a density infinity over here because of that side. This is a convective magnitude, which is we share the relationship and it shows that the stress tensor, which is going to be mu, I believe it's a mu, and then it's going to be U infinity, and it's going to be let me think, and then this is supposed to be L, L squared, I think. Okay, and then that would mean how do I get this? This shows you the V dot tau, I think, divided by v dot gradient v. Okay, and then the top is mu u infinity L squared divided by u infinity squared density over L. L goes cancel out, which means L, you flip it, it's in the bottom, that flips out, so L is at the bottom. Density infinity is the bottom, u goes on the bottom, and mu goes on top, which means this is much larger than 1 because the Euler's condition, or Euler's condition, which means that no, no, much smaller because it's reversed. So it's reversed, then 1, which tells me that v dot gradient v, no, v dot gradient plus dv dt stays, but we can neglect all the other terms. And then body force, that's what I forgot. Body force. Body force is deleted by Fond's number, so that's later on. And then we keep our dt plus the gradient dot parentheses dv equals 0. So next is energy. So no, we use T ds dt equal to the think, what was it? It was negative P gradient dot V. I think I got that. Tau bar gradient V plus what was it again? No, it was not plus, negative gradient dot Q dot. So you got that final form. And then what this is supposed to say, this is big D dt. So this is ds dt. There's a density here too. So that's a partial plus V dot convective S. Okay. So with that said, we can do order of transportation here. So let's look at order of, I think we look at this one first, right? I don't know why, but I remember P not having anything. I don't know why. I forgot. So that's one place to check. Uh, okay. So yeah, yeah, we're almost done. I believe something. I forget. Anyways, over here we have mu u infinity divided by L square, and this is going to be u infinity divided by L, and this is going to be divided by L. And there's going to be a k over here, and there's going to be a gradient of t, so delta t divided by what's the rest? It's going to be gradient by L, so L square, gradient t, gradient blah blah blah. U infinity delta S divided by, and then there's a delta infinity, and t over here is not delta, and then we have our L length, I believe, and we make them equal to each other. So this one mu U infinity square divided by L cubed, and this should give me delta S equal U infinity square divided by L cubed, L squared. And am I correct about this? I think I forgot something. T infinity and delta infinity. Okay, so now we can get 1 over RE easily by multiplying RE on top, which equals wait, something's wrong. This should not be true. Something's wrong. Something's definitely wrong. Okay, because right now you have it flipped. Oh yeah, no, I'm not wrong. U infinity, U infinity. Oh wait, I think U is wrong. Yes, erase this. This is supposed to be 1. Yeah, that's what I thought something's weird. Because I was looking at it and trying to figure out the next step. The next step wasn't getting it to me anywhere. So next over here is U infinity L, right? And then L square, so this goes away. So this goes away. Square, so that's L. And then divided by mu. So there's a mu on top and a U infinity again. So that gets canceled out with that. There's an L square, so this gets canceled out with this. And then there's a UU, so that equals, and then there's density infinity, so it's going to cancel out. So you get U infinity square, and there's a T on the bottom too. Divided by temperature, I believe, and then there's one length scale stay. I think it does. Anyways, 1 over RE. In terms of that, I think something's wrong. As always, I need to double check. But that, I'm trying to think right now. Something's definitely not right. We didn't do something correct here. B dot da 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 U infinity U mu mu U U lefty T square T infinity delta S divided by L that equal U infinity squared divided by L cubed over here L cubed L square U infinity U cancel out U density T infinity no yeah, that seems right, but I know it's wrong because there's some um I'm pretty sure this is supposed to be Mach number, and the other one is supposed to have Prandtl number. So that L doesn't make any sense. How doesn't make any sense? Ah, figured it out. You see this? It's supposed to be just L. So when this L happened, this canceled. It was L squared, so L canceled this one out. So this means this canceled this one out, which means this doesn't exist. Okay. So from this, I can tell you that T. Oh, did I figure out the A? What A is? A is D P over D rho in S equal A squared. I didn't do this. Okay. So, well, you can integrate all of these, and I didn't do any of that, did I? Okay, that's what I forgot. S1 minus S reference is what I forgot, which equals CP ln T plus uh minus, looks like it's minus eraser. Uh eraser again because this is wrong. Because it's T over T infinity or reference. And then this is going to be like this because you integralize it. Minus RG ln, and this one, let me think, is ds equal dh over here basically, plus okay, so I think it's dp. Right, let me double check if that's right. dp, that is right. That is right. That is right. dpt reference, oh, it's pressure. Okay. P over P infinity, which next thing you do is basically say Cp equal ln parentheses T over T ref parentheses Cp, and then this is going to be divided by P over P infinity R G, I believe is negative. Right? Am I right about this? I think I am. But yeah, and what we have to do is get this to obey. But why do we want this one? When we want S minus S over CV equal ln. I know what it is. Rho alpha, basically. I believe that's what we want. So this is not the one we want. Even if we simplify it, which we can, I think we want is this one. It looks more accurate because it has a relationship between S and CV and P and density. So let's try this one. I think I did the wrong one. Let me see this one. If we integrate this, it is S minus S ref, which equals CV ln parentheses P over P ref, parentheses minus CP ln over rho ref, and then it's ln of P over P ref, parentheses CV, and this is by ln of rho over rho ref, which parentheses by CP, and this must be like this. Which gives you 0, so this must be equal to P over P ref equal density over density ref, which equals to CP, and then we can say CV. If I got rid of this, and then P over P ref equal rho over rho ref, and that would be alpha. Okay. Uh, um, hmm, hmm.